Welcome to our Scale and Secure Part 3. This has been a three-part webinar series, and this is the final piece of it. Today, we are going to be discussing advanced practices in scaling and security. So just to dive a little bit deeper into the agenda, we'll be going over Zano team introductions first. Then we're going to jump over to testing new features, right? Like what you need to know when you are adding a new feature to your application and what are some of the best practices around that. We'll then move on to talking about best practices for security and how to respond to a security attack. At the end, we will allow some time for some Q&A and we'll wrap up the session. I do like to say that if you do have any specific questions that are specific to your projects or anything that you want to discuss more in depth, we do have office hours that we host every Tuesday, twice a day. That is the perfect time for us to go over those questions. Awesome. So let's go ahead and get started with some introductions. Michael, Chris, it sounds like you don't have to introduce yourselves. Everybody's very familiar with your work. So I'll give my first. I'm Liz. I'm the developer community manager here at Zano, and I will be your host today. We also have Chris Coleman and Michael Udinsky joining us today to present during this session. So Chris, I'm going to pass it over to you to do a quick introduction.
Sure. Hi, everybody. My name is Chris. I'm the head of customer success and community here at Zano. I'm super excited to be here for part 3 and give you guys a cool demo.
Thanks, Chris. And Michael, over to you.
Yep. Hey, everyone. My name is Michael, and I'm the developer advocate lead here at Zano. Thanks all of you for joining, and especially for those who have been with us for all 3 parts now of this workshop, and excited for another great session.
Awesome. Thank you, Michael. So this next part, Michael is going to be leading. We're going to be talking about testing new features. So I'm actually going to go ahead and stop sharing my screen and pass it over to Michael.
Awesome. Cool, guys. Yeah. So here to first talk about testing new features. So obviously, one of the major advantages of no-code platforms, just like Zano, is you can develop new features very quickly and iterate. It's important just to take a few things into consideration, such as testing these features as you are building and iterating and releasing them into your live product. So first and foremost, one key consideration is establishing performance baselines, right? And that is defining those key performance indicators or key KPIs, like response times, throughput, and resource utilization. So in order to do this, conduct thorough performance tests under normal conditions. We'll talk about load testing in the next slide. Have those baseline metrics across various usage scenarios. And make sure just to document and analyze those results so you can identify those bottlenecks and always think about areas of improving. So, one kind of example of this might be in an e-commerce scenario. Perhaps you're introducing a new search functionality into your e-commerce platform. So you've already established your baseline metrics of response time, search query throughput, and what kind of load that puts on your CPU and memory resources. The testing process, so performing those load testings to simulate what it's like with real user traffic, and then analyzing that. So comparing that new feature into what you already have established with your baseline to just really assess the impact of how that new feature is going to affect your application. And so next into load testing, which we just mentioned. So first of all, what is load testing? So it's a way that you can test to simulate user loads to assess system performance, and it really helps identify those bottlenecks, potential weaknesses, or any areas of improvement. And, why load tests? Pretty straightforward, but of course, we want to understand how the application will respond under various loads and heavy loads if you're stress testing it. So that what is optimal performance and reliability for your application and your server. And, when you think about load testing, it's important to really have sort of a user flow mapped out. And what that means is having a real world usage scenario. And this could be something like, a user logs into your application, they navigate to a certain page, maybe they, scroll a few pages, and then they start to interact with some requests, that are very specific to this user flow map that you've created. So having that real world usage scenario is very important. And then determining also usage load, right? So you're going to know sort of your app, typically the best, maybe the number of users you want to simulate. And then if, there's times in your application where you might see some peak traffic or a spike of traffic, account for those traffic volumes as well to see how your app and your server will perform under that as well. And then, of course, monitoring the effects of the new features. So this all sort of ties into the first couple slides, but, not only those, you have those baseline metrics, but now you're monitoring the metrics of the new features, right, to compare them against. So the response time, throughput, resource utilization, leveraging the API request history in Xano. You can easily filter response times to see what might exceed a certain threshold that might not be satisfactory for your application. And then you can even dig down deeper into there with pinpointing the potential bottleneck with those different timing details. So you can break down the request history into the different functions. So, you might see an API response that took a lot of time, but then as you dig down, oh, there's a single function that is that bottleneck. Maybe it's a query, maybe it's something else like an external API request. What can I do to account for that bottleneck from there on out? And that also gets into this idea, or this theme of observability and monitoring. And one of the ways that you can really take advantage of this, especially in this no-code space, is to leverage the NC Scale integration that we have native in the platform. NC Scale provides both observability and monitoring. And sort of, it's kind of important to highlight a little bit what the difference is of observability and monitoring. So observability really gives you sort of eyes and ears on everything. So, I think I've seen it described sometimes as, like an iceberg. Monitoring is sort of what you know about, right? Observability is kind of everything underneath the water, right? So observability gives you sort of all the data so you can go through and identify things that might be weaknesses, things that might be bottlenecks, so you can then monitor them. And with NC Scale, you can set up alerts and notifications for, when you're monitoring those potential weak points. Additionally, the resource monitoring graph with Xano, we're making some exciting updates to this over, the next couple quarters as well, but this will give you eyes and ears on your CPU and resource usage on your instance. And then just continuously monitoring, right? So as you are introducing new features, pay attention, see what the impact is. Sort of goes without saying, but also very important just to keep your eyes and attention on that. And of course, compatibility and smooth integration. So as you are developing new features, right, let's make sure they're working with our existing workflows. We can leverage branches and merging in Xano. So branches are a way where you can develop and test new versions of your business logic in API until you're at a point where you're ready to actually merge it into your existing workflows. And also, it gives you the ability to roll back very easily. So in the event that you do make a merge from one of your branch into, say, your live branches, if something goes wrong or you created a bug, you're able to go back to your previous version with a click of a button to provide that sort of safety net. Also, as you're testing, leverage data sources. So test data source is basically a copy of your database schema without your live data. So you can have, you can test all your API and business logic without affecting that of your user data, your live data, especially if there's existing workflows that sort of depend on that accurate live data, or you don't want to affect your user data. And so just digging deeper a little into branches here. So as mentioned, they're a way to develop and test new versions of your business logic and API. They're going to enable that seamless development in your workflows with merging. When you create a branch, once again, they are a copy of a source branch. They allow for the same editing, publishing, testing, and API endpoint usage. So what's really great about branches is there's a way to test them from a front end or from a live call versus just run in debug without affecting that live API call and that live branch. And then merging branches. So you can merge them into each other and retain that copy in case you do need that safety net to roll back. And then this goes hand in hand with data sources, and we'll go into a demo just after this to show what that sort of looks like. But just like you have the different versions of your business logic, data sources helps you have different environments for your database. Once again, separate than your live content, your live records, you can have your test records for testing. Very easy to sort of point an API call to that test data. As you can see here in the middle of the screen, you can either set a header from where you're calling the API with that X data source and then test as the test data source, or in a URL argument. Like if you're using a GET request, you can attach that to the URL as well. And once again, when combining test data sources with branching for your testing needs, it can become very powerful and effective for developing and continuing to iterate quickly. So with that, I'm going to switch gears now, and we'll jump into Xano and show a little demo of how you might want to think about just an example of leveraging branches and data sources for testing. So on my screen here, now we are in Xano. And so let's lay out this scenario here. Maybe you have a simple form submission on your app or website, so you can collect or gather different leads that you might need to reach out to for your sales pipeline, right? So if you could imagine a form where it's first name, last name, a company, a size, and an email, right? And this feeds into a Xano database, so you can have other workflows or automations to go along with it. But let's say that you're collecting these leads, things are going well, but you're noticing maybe some people are having some typos in that email field, right? And you want to adjust the form so they have to enter in the email 2 times, so there's a match and it confirms that, and so you're getting more valid data with more valid emails that you can actually reach out to, right? Of course, you want to keep your live form up because the leads are coming in. You don't want to stop that. So this could be a very good opportunity to develop the next version of the form on a new branch. So we can access branches here on the left navigation bar, just right at the top here. And you can see where always the very first branch you start at will be V1. And you can add branches here, merge them. You can even do comparisons. So I've already created my V2 branch here, which was a copy of V1. And I can go in here and edit the branch. And when we do that, we get this nice banner at the top to let us know, hey, you're actually in branch V2, where in your live branch is V1. So while API requests are going to V1. So we can come into my API now, and I can look, and I've already created this new version of this form, right? So I've added just another email input here. I've added a precondition, right, to enforce that these emails actually match. And then I'm adding to the database. So what's cool now, I'm going to jump over to Postman so we can sort of mimic what the live API calls, right? Because one of the advantages of branches is, we can actually run this live from, say, a front end or a tool like Postman outside of Xano, so we can see what it's actually doing, actually interacting with. And over in Postman now, and if you haven't used Postman before, it's just a way that we can make API calls, very effective tool. But in here, I've defined my endpoint URL. And what you'll notice right here, and hopefully it's not too small on your screen, but right after my canonical for my API group, you see this :V2. So we're actually able with Xano to identify the branch version of the API call that we want to send the call to. Now, by default, if there is no branch identifier, that will always go to the live API call. Of course, we can also strictly identify the live branch if we want to. But for any of our non-live branches, if we want to call it, we do absolutely need that identifier. So you can see here, I can actually go ahead and now run this new API call, and I'll send this request, and we should get a response back, right? And what's cool is we can even access the request history from our different branches because we're sending it differently. And if I just give a refresh here, and there is my API call. So this is specific for V2 branch. And now if we go to my database, we should see well, that got added. But wait a second, I'm testing, right? Maybe I don't want to be sending these test calls to my live data source because once again, maybe I have some triggers or some automations that work with these leads coming in, and I don't want that to interfere with that. So we can actually create a test data source, and our data sources just right under our branches can be managed right here. So right now I just have a live data source, and I can simply add my test data source. And let's jump to my test data source. And now you can see I have my same database structure, but I actually don't have any records in here yet because this is going to be a separate environment for my database. And so if I do want to actually send my API calls to my test data source, well, once again, what I can do is I can set a header from where I'm calling it. So here in Postman, we have the ability to set headers. So I'm just going to go ahead and set that X data source header name. The value will be test. And now when I run this, and let's go ahead and just put in, let me go back to the body here. That's my response. I'll just go ahead and put some new identifier in there, the first name, so we know it's a new call here. And if I go ahead and send this, well, now when I jump back to Xano and I just refresh this database, you can see now that my test submission went into my test data source. So now I might not be affecting any kind of live automations or anything that I happen. And if we jump back just to my live one, we see that was my first entry, but that 1, 2, 3 obviously went to my test data source and didn't affect my live data source. So there's just sort of, very high level, but you can already see how powerful that is to sort of leverage branches with data sources at the same time for testing purposes. So with that, I'm going to switch back to Liz for the next section.
So today we're going to be discussing the critical importance of security in development and some common security threats that we are aware of or that we need to be aware of. So in application development, security isn't just a nice to have. It is absolutely critical. So let's take a closer look at some of the common security threats and the impact that they can have. So there could be data breaches, unauthorized access, vulnerabilities are some of the most common ones that we face. And the consequences of these breaches extend just beyond a financial cost, right? There can be significant reputation damage to that application. So to address these threats, we need to shift our security strategy from being reactive to proactive. Rather than just responding to threats as they arise, we should aim to anticipate for these and mitigate before they occur. So now let's talk about one of the fundamental security measures that can be implemented, which is requiring authentication on APIs. So by ensuring that API endpoints are accessed only by the intended users, we can prevent unauthorized access and protect sensitive data. This authentication process basically involves logging in and receiving a JWE token, which serves as an encrypted token for user authentication. I basically kind of like to think about it as like a key that users can use to unlock different API endpoints that require authentication. Another important security practice is separating user data. Users should only have access to their own relevant data, such as account information or shopping history, if we're talking about like an e-commerce application. And this principle aligns with role-based access control, which we will discuss next. Now, RBAC helps us define rules and roles for users within our application. It is something that we discussed in our previous workshop as well, so feel free to reference the recording for that. Basically, by assigning different access levels based on user roles, we can restrict access to data and APIs and ensure that users only have access to what they need. Now, Michael, I do believe you have a demo prepared for this, so I apologize for all of the swapping of the screens, but I'm going to hand it over to Michael so that we can see a demo.
Okay, awesome. So we're looking at a Xano database right now. So let's imagine that we have sort of like a task management or to-do application. You can see that all the tasks are put together here in this task database, and we have different users assigned to them. So we should only have the tasks that belong to the user viewable to that user, right? We don't want, Cameron seeing the tasks that belong to Liz and myself seeing the tasks that belong to Chris. So how do we ensure that that doesn't happen? So let's jump over to the API, and I'm just going to jump into this demo group where we had our form from earlier. And let me actually just, and so right here, I can go ahead, I'll add a new API endpoint, and I'll call this my tasks here, if I can spell correctly. Awesome. So we want to go ahead and get our tasks from the database. So the first thing I'm going to do is have a query all records from my task table here. And right now, if I were just to run that, well, we're getting all tasks back. And going back to one of the security best practices, right? This endpoint right now doesn't require authentication. So we want to make sure that that's going to have user authentication enabled, right? And so now if I try to run this, well, I need an auth token, right? So let's say that, okay, well, now I'll go grab the auth token for myself and I can run this, right? So that's a security best practice, but I'm still seeing tasks for every single user, right? So still not quite there yet. Well, because we are requiring that user authentication, Xano's actually able to grab the unique ID of the user. And why that's important is now we can use that to actually filter the data. So if I go into my query all records here and go to buy custom query, I can actually define the rules of how I want to query the record. So I can go ahead and say that field that's referencing the user in my task database, I can set this equal. We have something called auth ID, and this is accessible once you have authentication turned on in the API endpoint. And so now let's go ahead and save this. And so now if I run this and think myself as user 3, if I go ahead and run this, we should only see tasks for user ID 3, which is myself, right? And we can go ahead and pick a new user. Let's go ahead and pick Chris here. And now we only see the task for Chris, our user 1. So just to take it a step further, right? So that's separating user data. Now there's also this idea of role-based access control, and you can actually have user-defined roles to have even different rules on how you are restricting access to your data. So if I go into my user table, you can see I've defined some different roles here for our users. You can see there's an admin role, and there's these various staff roles. So let's say that in our task management app, maybe if you're an admin, you're able to see everyone's task, right? If you're a staff member, you can still only see my tasks. So let's go ahead and create an endpoint to see all those tasks for the admin. So I'm going to go ahead and hit start from scratch here. And I'm just going to call this, we'll call this C task here. And so once again, we'll have that query all records from our task table, right? We'll turn on that user authentication, right? And so this time, right, we don't necessarily want to filter the records, right? But if I'm a user that's other than Chris, like if I go to myself here, I shouldn't be able to run and see all these records. Once again, we're using user authentication, so we're able to identify the users. So what we can actually do is I can go ahead and do a get record from the user table, and I can look it up by that auth ID. I'm just going to save this and drag this first because in our function stack, order of operations matter. And why did I do that get record first? Well, that's because I wanted to get the user object. And in the user object, we can find the user's role. And now we can define the rules in our business logic of what we want to do based on that role. So next, I can actually have a precondition. And preconditions enforce that something must be true. So I can go in here and say, well, my user1 variable, which contains my user object, using dot notation, drill down into the role and say that must be equal to admin in order for us to query those records and see all the tasks, right? And I can even define a error message here and say like, you do not have the right access, or it can be whatever custom error message that you might want there. So now if I go ahead and run this, right? So let's go ahead and run this for Chris, who's an admin. Well, we should see all of our tasks come back, right? So let's go ahead and next grab Liz. And what do you know? We hit our precondition. We do not have the right access. So it's blocking anyone with a role other than admin from actually accessing this data. And, you can go ahead and use tools like preconditions, and even conditionals are a very powerful tool to leverage if you want to sort of set different paths in your business logic to serve up different data depending on what someone's role is defined. In this API endpoint here, we had a precondition, so that's just going to throw a hard stop, a hard error if you don't have the right role. Of course, you can set using leveraging conditionals, set different paths and return different data depending on that user role. So with that, I will pass it back to Liz.
Awesome. Okay, perfect. So now let's discuss API access on database fields. So by defining access settings for database fields, such as public, private, or internal, we can control how data is accessed and ensure that sensitive information remains protected. And finally, we would like to discuss Swagger documentation. So Swagger documentation is automatically generated, right? And it allows us to grab information about our API endpoints. We can also control the access to this documentation to ensure that it remains secure and that only authorized users have access to this. So back to Michael for a quick demo on the Swagger documentation. Michael, I will pass it over to you.
I'm going to go ahead and share my workspace here and into this API group on branch v2. So in your API group, you can access your Swagger documentation right from this button here or from the settings, a couple of places. So when I open this up, you can see our auto-documented API endpoints, which is super awesome, especially when working with teams and maybe you have a front-end team to have all your APIs automatically documented in one place. It's automatically synced with all your published API endpoints in Zano. Super awesome. So you see when I open this, in our URL here, there is this token parameter. So by default, if we go to our settings here, the Swagger documentation is private. It requires that token in order to open it. Now there's different settings as Liz mentioned, right? So there is public. So if I go ahead and save this and I reopen this Swagger documentation, you can see I don't require that token to actually access that, right? And there's definitely some use cases to this, right? I mean, you've probably been on, various services where, the API documentation is maybe accessible right through their website. Of course, if you have that authentication, that authorization, someone might actually need to sign up to get that token to actually interact with these APIs, but you can see maybe the documentation there. Now, of course, there's another setting here. We can completely disable these from being discoverable. So if I just save this, right, and I come back to Swagger here and let's try and refresh this, well, we won't even be able to access this at all. So if you need to, for whatever reason, completely access that documentation, that is totally acceptable there and able to do so in the settings. If I go back to, and let's go ahead and enable this, go back to private here. So if I refresh this, we should still have the same token, but if for whatever reason you need to revoke that token and set a new token, you can also do so just in the settings, just very quickly. Just reset that token for documentation access. You can see that's been updated. So if I refresh this with that token in there, well, I'm not going to be able to access that because there's a new token now. If I open it once again, you can see this token is going to be different from this previous one. So that is pretty straightforward, but very important to know those different access settings for your Swagger documentation. So I will pass it back to Liz one more time now.
One more time. Awesome. Thank you, Michael. So in this segment, we're going to be discussing the crucial steps to take when you are faced with a security breach. So we just want to give you some steps to mitigate the impact and safeguard your system and data. So first, let's talk about some of the immediate actions that you can take when a security breach occurs. So first, we just want to make sure that you disable the API endpoint that is being impacted. to prevent further external access. If you have security policy control, you can leverage the API address deny list. So you can use this to block specific IPs from accessing any APIs in your instance, and that will basically tighten up that security measure. Additionally, you can leverage middleware to check IP addresses and terminate execution if necessary. So this just basically adds an extra layer of protection to your system. In case of a security breach, it is crucial that you reach out to support immediately. You can contact us via support@cieno.com, or you can contact us via the support chat within the product. So once you reach out to us, we can provide guidance and assistance that is more tailored to your specific situation. Now let's discuss the next step we can take to make sure, that everything is being tightened up, and that is making changes, right? So one thing that you can do is create an IP blocking table that allows you to add IP addresses on there that you want to block, and you can update those as needed, which provides you more flexibility and control over who has access to your system. And as Michael mentioned earlier, right, Cieno allows you to iterate pretty quickly. So at this point, you can make any changes that you need to your impacted API endpoints to make sure that if there was any logic that was creating a loophole, that gets patched. And then data cleanup is another critical step of responding to a security breach. So one thing that you can consider is cleaning up that data, right? So you can identify and remove any spam or fake accounts from your database tables to ensure that your data remains accurate and secure. However, if you are going to be doing this, it's just important to note that you can export those database tables before making those changes. That way, if you need to restore anything, you have that. You can also utilize instance backups and export any request history to provide you with further avenues for analysis and restoration. So that was the last slide for me. I'm going to pass it over to Chris for a demo on this.
Give me 1 second here to share my screen, and I'm going to just give you a quick demo on responding to a security incident. So here's the scenario. We have an application. It's like an e-commerce application that users have to sign up for before they can utilize. And what we've noticed is a significant increase in API requests beyond what is our typical usage. Now, that's not necessarily a problem in and of itself, but we probably want to dig into it a little bit further, just so we can make sure that nothing crazy is happening. So what we can see here, just dialing down into our request history a little bit, we have our sign up endpoint here, and we can see if we scroll down here just a little bit, it looks like we had a ton of users added all in a super short period of time. And that seems a little bit strange. We didn't push out like a big sale or a huge announcement or anything like that. It's really just business as usual. But you can see with all of these requests, and they kind of have the same time on them. And with our graph here, we had almost 100 signups, all in basically just like one quick swing. So we probably want to dig into that a little bit further and see what we can find out. We can, of course, click into these requests, and we can look at the inputs and things like that. And if we look at some of these, we can see the names don't really make sense. It just kind of looks like garbage data, which is another kind of red flag. And that essentially tells me I really need to investigate what is happening here. I may have a problem. So the first thing we can do is we can go up here to our endpoint settings for our signup API, and we can just disable access to this entirely. So there are no more signups allowed on our application, and we'll publish our changes. And that's really just to kind of stop the bleeding, essentially, is what we're trying to do there. The next thing we're going to want to do is we are going to want to start taking steps to block traffic from that problematic user, that bad actor, right? And so continuing to use the request history and leveraging the metadata API If you're not familiar with the metadata API, it's essentially a set of APIs that Xano provides you to programmatically manage content inside of your workspaces. And one of those APIs includes searching and filtering your request history, just like you can do inside of the product. But if we use the metadata API, we can then work with that data inside of a function stack. So in this very simple function stack here, all I'm doing is I'm creating a variable with a timestamp, and I want to look at traffic for the last 5 hours. I think I may actually need to make this a little bit longer just to make sure that we get the information that we're looking for. And then I am sending that request to the metadata API, and I'm looking for any requests that were created after that timestamp that is generated in the first step. And then I'm just looping against those requests, and I'm pulling out all of the IP addresses of those users that made requests during that time to my signup API. So when I run this, you can see that we have one IP address in here. We don't need to worry about this one. This one is coming from my metadata API requests earlier. But we only have one IP address in here. So what does that tell me? That tells me that all of the requests that went to my signup API that were created after this, essentially like when the spike started, they all came from this one IP address. So thankfully, it doesn't look like I'm dealing with a mass, bot attack or anything like that. It looks like I just have one person going a little crazy. So I'm going to want to copy that IP address. And I have a couple of options for how I proceed from here. I can go to my instance settings. And this is, of course, if you have security policy available, which is only available on certain plans. But I can go to security policy and I can deny their IP from here. I'm not going to do that because that will actually cut off my access to the instance entirely, which would not be great for the demo. But all I would have to do is save those changes, and then they would be immediately blocked. So let's say that security policy is not an option for us. That's okay, because that is when middleware comes into play. So with middleware, we talked about this a lot during our last session, but it essentially allows you to build a function stack that you can apply across your entire workspace all at once. You can also dial it down to API groups or APIs themselves. In this middleware, I'm using a precondition, the same function that Michael demoed earlier, to check and see if the user's IP address, which is pulled from the request headers, we maintain a variable for you, so you can work with request headers inside of the function stack. We're just checking to make sure that that is not equal to that user's IP. So that means that if this precondition fails, so that is that problematic IP, then we just return this unauthorized error message. So they are not able to continue with execution. So we have demoed 2 different ways to essentially just cut off their access entirely, which is great. So now that we have stopped the bad actor in their tracks, we want to start thinking about what are the next steps. Of course, we definitely want you to reach out to us via support, even if it's just to let us know, hey, I had this thing happen. I want to make sure that I'm doing everything I can to make sure this doesn't happen again. What do I need to look out for? That kind of thing. We're always happy to help. And some of this is going to be different depending on your specific application. So we're happy to kind of, look at like specific details there and give you some guidance. But let's just say I reached out to support. Support said everything looks okay. It's probably time to start cleaning up the mess. So how do we do that? We are going to go back to our best friend, the request history through the metadata API. Again, we're making the same request here, but the requests, I'm actually going to do a stop and debug here and show you what I'm getting. So I'm looping against those requests, and let's go ahead and just run this here. So those requests, you can see, of course, all of the headers, but the really cool thing here is we can see the inputs. So we can see those usernames. So that will give us some really quick access. And I'm realizing I think I need to modify this one here. Okay, so we're at a day, so that should be fine. So we have the name of essentially all of those users that made problematic requests. And so with that, we can just very quickly do a for each loop and delete that user record. So this will get the value from the name path right here inside of this input object. And we delete those records, and those user records are now gone. They're not really going to hurt anything by being there, but of course, good hygiene, we want to make sure to remove accounts that we don't want in our user table. And so we've cleaned up our data. Everything is great. We've taken a couple of steps to block that user's access, and we're pretty much good to go. The last thing that we want to think about is some of those proactive fixes. We've handled the reactive side. Now we want the proactive side. What can we do to prevent something like this from happening in the future? There are some things you can do on the back end and some things you can do on the front end. On the back end side, limiting Swagger access is a great first step to take. You want to make sure that nobody can, kind of fish out that URL and start looking at your API documentation. We can rate limit our sign-up endpoint. So I'm going to show you how to do that. All I need to do is add a simple function here. It's called rate limit. We have that available for you to use. The rate limiting function just has a few parameters. We have a key. The key is to essentially store rate limiting data. So I'm going to call this RL signup because we might have rate limits on different endpoints. So we want to make sure those keys are unique. I only want this endpoint to be able to be called one time every 60 seconds. And I'm going to go ahead and give it an error. I'm going to say too many requests. We'll go ahead and save that. And as Michael noted, order of operations is important. So we'll drag that to the top and we're going to publish our changes. And so now with that rate limit in place, what I should be able to do here is I'm going to create a new user. So testing RL123 is that username, and we have the password here. We'll set a request. What did I do here? What happened? Oh, I disabled the API. That would do it. All right, let's enable the API and we'll publish our changes. There we go. And we'll send this request. So we get 200 okay, makes sense. But if we send another request, you can see we get too many requests and we have our error message there. So now our sign up API can only be called by one person. It's per IP address with the rate limit. So one IP can call the sign up endpoint one time every 60 seconds. And we may want to make that a little bit longer just because of the nature of the API. But yeah, just with one swing, new function in our function stack, our sign-up endpoint is now rate limited. So that could essentially never happen again. There are a couple of things that I can't really demo here just because they would take a little bit too long, but more so just applying more suggestions to you based on your use case. Geolocation blocking is another option, which we have a function for that, I believe. So we have an IP address lookup function here, and you can feed the IP address from the request headers in here to get location data, and you can leverage that location data. So maybe your shop is only available in the United States. Then you can make sure to just block IPs that would not be able to use your services anyway. We can implement email or phone verification. So requiring users to verify their account by clicking a link in an email, or maybe we are sending them an SMS to their phone. Those can all be implemented on the back end with maybe a little bit of front end work, just depending on what the exact method is. On the front end side, you would probably want to think about using CAPTCHAs. There are many flavors of that you can implement, or even something like a honeypot field where a bot will essentially scan your page code and fill in all of the fields to submit those requests as fast as possible. But you could then implement some logic on the back end that says, if this field has a value in it, deny the request. So you kind of cover yourself from multiple bases beyond just that IP address. But for us, for our specific scenario, implementing that rate limiting in our signup API is all we needed, because we only had that one bad actor and we have blocked their access, and we are good to go. So that is just a quick demo on some of the things you can do during and after an incident.
We're going to hop over to the Q&A piece of this session. We have about 7 minutes left, and I think mostly everybody has gotten their questions answered in chat. I do see one that came in from Tomas. So this one says, are there any guidebooks or pro tips which explains such cool tricks?
I would say our YouTube channel is probably the best source for things like that. We get to have a little bit more fun there than our documentation sometimes. That being said, I do want this to live in our documentation as well. We have a little bit of a documentation revamp project going on behind the scenes, so you should see a lot of improvements and a lot more real world use case information like this. And of course, the community, Xano community, community.xano.com, fantastic for discussing things like this with other Xano users, which is sometimes the best source of information.
One question, if we still have a minute. So I've been working with Xano for already maybe 3 years, or something, maybe 2, maybe 3 years, but haven't still managed to get the authentication part going. I didn't really need it because we don't even have like users, but using it for business data. But I would really like to get the authentication going in the future. And it's just interesting how it actually works, like in the background. So do we just add, like, let the user pick the password and username and just added it to the database, and it generates the token on the fly and associate, like, can we use only Xano for authentication, or do we have to use some other authentication means to work with users?
That is a great question. Just to confirm the first piece of it, yes. When you use authentication with Xano and you select the user table, it automatically creates specific fields for you. I believe those are name, email, and passwords. So that's some information that you can ask for your users to fill out. However, you can definitely modify that by selecting different field types, depending on what you want to collect from your users. And then there are some endpoints that automatically get generated for you as well, which you can definitely modify too. But the ones that get modified, the default is basically checking for a user in the user table, and then it has a precondition, and then it adds that record to the user table. And then the last step is creating that auth token. And then that basically is what you can return back to the front end. So that's if you wanted to use it with Xano. However, we do have some extensions built out in our marketplace. So if you wanted to use like Google or Facebook or Twitter, you can use those too.
Interesting. So when someone logs in, Xano basically checks in the backend if the combination of email and password is correct, and then returns the GVT token, or what token, or it's called.
Yeah, this is something, too, Tomas, I covered this during orientation, and I'm sure we have videos out there as well, but if you wanted to join like in a live setting, that link that I provided at the beginning of the session, you can register for orientation, and I cover all of that there too. And I do it every week, so yeah, feel free to join. Yeah.
Perfect, thank you.
Thank you, everybody, for joining us today. I'm going to stop sharing my screen here. Again, would love to see you come to these upcoming ones. Let us know what you want to see from us. We definitely want to make sure that these are valuable for you. And if you have any questions after today's session, you can always find us in the community. And yeah, we hope to see everybody around.